In this video, we will be studying another modeling concept, namely varying parameters. Varying parameters are closely related to exponential smoothing and credibility adjustment of parameters. As in the last video, we will be using the triangle group CS5. If you don't have the database open already, please open the workbook 104A database and then open the triangle group CS5. You can see I have it selected here. We'll load the model with hetero. It's a model we created in the previous video. Double click on it to open it. Alright, and you can see we haven't had this model optimized yet. We've still got these blue lines in the display. Let's optimize it now by clicking on the double O just under PTF. And we'll save that model now. It's opt with hetero. So the M with a downward arrow, click on that to bring up the save model dialog and just type in opt with hetero. You can see I've already saved it here before. And I'm just going to overwrite that now. Okay. Alright, we're now going to open the model parameters. So the model parameters is the third button in on this toolbar, just under database. You can see the tooltip comes up model parameters. Click on that. We're now going to minimize regression tables, so click on the downward arrow, minimize regression tables, and then just minimize the model display as well, and tile again. Okay, so we should end up with these two windows being displayed. What we're looking at here is linking the model parameters in this display on the right to the table here on the left. Now, what we see is these large numbers here under initial variance and then gamma variance. And what these large values are the L variances, and what it means is large, and whenever you have a large variance here, it means use the data to estimate the parameter. Don't use any other previous data, etc. So we've got an initial value here of minus 0.33, but we've got an initial variance of very large, so it uses the data between at 0 and 1 to estimate this trend. Similarly, between 1 and 2, we've got another large variance. So it means we're not using any of the information in 0 to 1. It's a new parameter. We're using the values between 1 and 2 to estimate it. When we've got this initial gamma of 0 with initial variance of 0, that means that we're saying we know the parameter is, and we know that it exactly because our initial variance is also 0. So we've set it to 0 exactly, and that's what's in the that's what is represented by the red vertical line here. Okay. When we have a 0 in the gamma variance, all that means is use the last parameter as the estimate. So in this case, between 3 and 4, we're not estimating a new parameter. We're still using the 0 parameter because that was the last estimated parameter. Similarly, between 5 and 6 and 6 and 7, we haven't estimated any new parameters. We're using the single parameter between 4 and 5 to cover 5, 6, and 7. So it's actually 4 to 7 is estimating this parameter. And so on. So 8 to 9, you're using the remainder of the data in the triangle to estimate that parameter. Just as we've got a 0 parameter here, we could actually enter in some other values. So for example, 0.1, if I wanted to set that exactly, I would set the initial variance to 0 as well. And we're going to use that for the remainder of the triangle. If we click estimate, then it's just going to put that 0.1 parameter into the model, and you can see that you now have a downward trend in the residuals here, which means because the trend in the residuals is the data minus the method, the trend in the method is too strong, and in fact the trend in the data is actually negative, so it's way too strong. Let's go back to our previous model by clicking the load model button, second button in here, and going back to opt with hetero. Alright, so now we've returned back to this previous model. So what are we actually saying here? So if we come back to the PowerPoint display, I've just created a blank slide, and I'll just get a highlighter and change the color to red so it's more visible. Alright, so what we're saying is we've got these, let's say this is our gamma, and we've got a measurement at j minus 1, j, and j plus 1. Yeah. Now what we're trying to say is that we can estimate this parameter between j minus 1 and j as being gamma j, right? And we can estimate the parameter at gamma j plus 1 is equal to my gamma j plus some variance, which we'll call delta. Okay? Now, if you make delta large, then no matter what you put into gamma j, you're not actually gaining any useful information of that, because the variance swamps this initial estimate, so that you effectively are equally better off just to estimate gamma j plus 1 separately. On the other hand, if you make delta small, then you're setting the parameters equal. So if delta is 0, then you have your gamma j plus 1 is equal to gamma j. And if delta is large, then gamma j plus 1 is a separate parameter to gamma j. Alright? Effectively, because you don't know anything about gamma j plus 1. And as we showed in the Exponential plus display, you can do the same thing by actually setting what gamma j is. That was when I set it to 0.1, and then we set delta 0 so that gamma j plus 1 equaled that 0.1. Okay, so if we turn back to Exponential now, and we've loaded our model opt with hetero, we can see that in the title bar here. Let's go to the model display as well. So I'll minimize the model parameters for the moment, open the model display, and just tile minimizing regression tables. Okay. Now, these grey bars, although they're not shown in the window here, are actually L's. Okay. Now, but for the accident direction, we estimate these a little bit differently. And I'm going to have to change my modeling preferences so you can actually see what I'm entering in here. So I'll just do that now. So I'm going to Options, Graph Preferences, and I'm going to change back to base so that we can see exactly what numbers I'm entering on the display. Because in my previous settings, white on grey isn't very visible. Now, if we right-click on these displays, then we get the L parameters, and that's what was done in the previous videos. But if we left-click on them, we get these D parameters. And what D is, if we open the model parameters, again, go to accident period parameters, you can see that these initial variances are now, they're not 0, but they're not as large as L is either, so they're using something between. Okay, so if we go to the manual now for a second, to help manual. Before we go further, let's actually look at what the equations actually are. So we're going to go to section 5.2 in the manual. So just open the bookmarks, going to 5.2, and I'll just make sure that's visible. Okay, and I'll just find the equations that we want. Okay. Yeah, I want these equations at the moment. So what we're saying here, like in my PowerPoint display, we're saying we've got this alpha level, alpha t, and we can estimate it by saying we've got alpha t minus 1, so the previous value of alpha plus some variance factor, and we link in the variance being large means we've effectively got a new alpha level. If variance is small, we've got something close to the previous alpha level. So this is not unrelated to exponential smoothing. When you take some value of k with k such that all these add up to 1, so that you have k times the previous value plus some k of the value minus that, etc., giving weight to these previous values of n in order to estimate your next value of y. Alright, so and that's also a credibility formula as well. But what we're using that is that we can extend this for estimating our parameters. So what we can say is that we have a previous estimated alpha parameter, and we can add some variance function onto it in order to help us estimate alpha t, which means that we're using more than just the information at between alpha t minus 1 and alpha t. We're also using the previous values as well. And what we see is the same as before, that we have this variance equal to 0, we have the alpha t equals alpha t minus 1. On the other hand, if this variance is large, then we end up with a new parameter between alpha t minus 1 and t. So if we come back to Equus then, we can see by adding these d's, we only actually had a small change in the residuals. If we change them again by adding the left, changing them to 1s, estimate, it's moved up a little bit further. Again, 2, and then it's changed even more. And as we add more after 3, I don't think it will change that significantly in the display. So very slight changes there. 5, barely any movement. Nothing happens. And then using the information just in those periods so that they're our full parameters. Okay. Now, what we normally do when we're modeling is adding the parameters as outs, so that the optimization routine will actually optimize it to find the most appropriate level of the variance based on the BIC. So what the algorithm actually does is it minimizes the BIC and finds the most appropriate variance factor to do that. So what we'll do is we'll add those 3 parameters there, 80 and 81 as well, and add 1 at the beginning where there are potential level changes. So we'll do that and click estimate. Okay. And now we'll go back to the model display. Right. And you can see there's pink one, so that pink level is going to be going first once we optimize. Let's click on the single O to do that. Do it again. It's going to remove the next level. Do it again. It's going to remove the next pink one. Another pink one. Now it's got this green indicator here. Now what the green indicator is that the parameter is set, but it's not necessarily at the most optimal level of the variance. So the next time we optimize, it's going to save it as sorry, once it optimizes it, it's going to set the most appropriate variance factor between it. So let's save this model now as it's actually before, because we haven't optimized yet, and I'll call it 2, so before opt with hetero 2. Okay, and we're going to optimize. Okay, and it's going to set it to, if I just expand that alpha accident year out, it's going to set it to a 2. So if I look at the logbook, what we'll find is if I go and set that to a 1, if we're looking at the BIC is expected to go up. Then I'll right click to change it to a 1, estimate, and the BIC went up to 101.7. If we change it to a 3, estimate, go into logbook again, it's 101.4. So both of them are above that 100.8, which is actually our optimal setting of 2. And I'll right click it, not left click, to change it to 2. Okay, look at the logbook. Yeah, it's a 100.8. Okay. Now, in the right-click menu, if you're looking at these displays, you've got partial weights here with the 2. You can right-click, reinstate only alphas, and what that does is if you've got an optimized model already, but you want to see if any other changes that you've made in the models, for example, removing points as outliers, maybe adding a few other parameters, but you want to see just how it affects the alpha optimization, you can right-click, reinstate only alpha parameters, and that just sets the alphas back up to full parameters so that you can then optimize them again. Because the optimized routine only works on L parameters, it doesn't work on something that's already been set to a 2 or a 3. And by reinstating only L the alphas, you're not changing these zeros back to parameters again, whereas if we'd right-clicked and said re-estimate all parameters, it would reinstate all the zeros to be parameters to be estimated again as well. Okay. So why is varying alpha important? Well, if we're looking at the trends projecting on the three directions, so we're looking at this type of slide here, where you've got your calendar year affects your accident and development, and the accident projects onto the calendar years. Then whenever you've got a small number of points, because going down this section triangle you've only got a small set of points here, you want to be able to distinguish between what calendar trends are and what accident year levels are. And in order to make that more effective, if I just resume the slideshow, actually it might be easier to jump to that slide so I can draw on it. So what we're saying is that you've only got a few number of points in that column, part of the triangle. Right. So you might only have 5 points down here. You're wanting to estimate a new alpha, but at the same time you're wanting to estimate your changing calendar trends here as well, which might only be based on these points in this period. So in order to do that effectively, you need to be able to relate your alpha at t with your previous values of alpha in order to make use of that information effectively, so that you don't end up with a state that you cannot actually estimate the regression equations. Right, because your normal equations aren't solvable if you've got too many parameters relative to your number of points, because you're not going to end up with solvable equation. You're going to end up with something like 6 equals w plus d, and have another equation down here with 12 equals, say, 2w plus d, and you can't solve those equations with one set of solutions. That concludes this video on varying alpha, and we'll continue with other modeling examples in subsequent videos. Thank you.